Hello, this is John from Indiana. Welcome to Radio Hound Tube Radio Restorations channel. Today we're continuing on with the understanding the tube radio schematics, and we're going to go on into the detector. We talked a little bit about the detector stage last week. We're going to finish up on the detector, and we're also going to talk just about the amplifier section. Then we'll finish up on the final end of the radio on the next video. I think we can get this done in the next two videos as far as this piece of the schematics. There's reasons why I'm taking you the route we're taking. It looks like maybe I'm jumping around places, but it's all going to come together here in the end, and you're going to kind of see, okay, this is why we did what we did. So I hope you enjoyed today's video, and I hope we can bring stuff to you where you feel comfortable and you think, it's a lot easier now for me to understand what's going on here. I hope I've enlightened you on some things. I know that, the experts are sitting here cringing, but eventually we're going to get there, and you guys are going to feel comfortable doing what we're doing. So, hope you enjoy today. Thank you.
Come here, look at that. Oh my goodness. Oh, are we going to do something today? Are we doing something? You want me to rub your belly? Yeah. I'll rub your belly. Wait a minute. What are we doing now? Are you thinking about all the stuff we got to do today? Are you thinking? Hold on just a minute. What are you doing now? What are you doing? Huh?
Okay, just to recap a little bit, we're working our way across here, and the whole purpose of this is to show how the audio signal travels through this radio, how we get from coming in on the antenna till we come out here on the speaker on the other side. We already talked about the front end section here, tuning the RRF, getting it nice and clean coming into this converter tube. We talk about the mixer oscillator section where we bring in that signal from here to give you that frequency coming at that, and then we get the result of those frequencies, which is that IF frequency of 455. And then we talked this last video, we talked about the IF section, how we tune each of these two IF coils, and we make them at 455, so only 455 is coming through, and that's what your carrier signal will be converted to 455 from this picture, and we're going to only bring 455 carrier through here. Well, what happens next, and this is going to be into our next section for that detector. I alluded to some of this last video, but I'm going to go a little more depth now. I'll be honest with you, as I've told you in many of these videos, I'm not an expert. I'm self-taught. Most of what I've learned is just from watching YouTube videos, but most of the self-taught is just hands-on. I've done a lot of radios, and the more radios you do, the more you learn. You learn when you're underneath the radio and you're trying to figure out why it won't work. It's something that helps you to learn quickly. So a lot of times I learn something, but I don't know what it's called or how it's said. So I'm still not a good teacher. I try to. I think I understand a lot, but as far as me conveying that understanding to you, I may be a little weak on it. So I will correct things as I need to. Okay, so remember you got 455 coming through here, and remember that 455 is on this carrier wave. This is going to be 455, frequency at 455 coming through that IF section, okay? And so that's where we're at right here. And so this is our first IF, and that's our second IF. Sometimes there'll be a third IF in most of these old radios. So This one has 2 IFs, and you can always tell them because they're equal, pretty much equal coils, and you don't really see that anywhere else in the radio. So you can kind of tell your IF section because they're facing each other, and then there's always a tube in between each one. If there was a 3rd IF, there would be a tube in between that one too, because each one of these is amplifier stage. So you have an IF, an amplifier to make the sound better and louder, and then another IF, and if you had a 3rd IF, you would have another amplifier, and then you'd have your detector tube. Now what happens here, and I alluded to this, we're going to take that carrier wave, and now we have to strip the carrier wave off, and we have to come out with clear audio, only audio coming out on this side. The carrier wave goes away right here. So after we pass over this coil, we went this coil, and then it jumps over this coil, and it goes through that tube, amplifies, comes into this coil, and then it jumps over to that coil. When we get into this side of the coil, some things happen. Now this particular model, and it's taken me a while to understand how this works, because most of them I'm used to, there's a little 1 or 2 diodes coming out right here at the edge of a tube, but this is just a triode. This is your cathode, then you got your grid, and you got your anode or your plate, and it's only got 3 parts to this tube. Okay, so what happens here is it has to rectify that modulated signal, and I'll explain all that in a minute. But another thing happens too, is we have to strip that carrier off, okay? So the carrier, this green color right here, and it is green, this green color right here has to go away, okay? So what happens is they create like a little pi circuit right here, and when it gets out of this last coil, that 455 carrier wave will be stripped off right here through this pi circuit. Pi circuit is like a resistor and capacitors in parallel with each other, okay? And what that does, as far as theory, I'm not going to tell you because I can't really explain that, okay? But what it does is it allows that modulated carrier signal to be stripped off here to ground, okay? It'll go out to ground. That modulated carrier signal is going to go away, all right? So while that's happening, you're going to have simultaneously happen over here, and what this circuit does, this don't have diodes, this just has a grid. Well, this grid, this tube is set up in this whole setup, and then like I say, here's where I'm going to get in trouble with terminology, because I know what's going on, but I don't know how to say it. But it's in a nonlinear fashion, so when it's nonlinear, whatever happens at the grid is going to be reflected on the plate, and not just, I don't know how to say what I'm trying to say, but bottom line is, if you're going to go positive, this is going to go positive, it's going to go negative, it's going to go negative, but it's going to match, this plate is going to, the anode is going to match whatever's going on here at the grid. All right, bottom line is this cathode heats up, you got thermonic emissions, and then you're going through this grid. Well, all your signal that's coming out of this coil is still, that signal is modulated signal. And so it's still, when it's modulated, it still looks like that with the top and the bottom like it does. But when it gets to this grid right here, what's going to happen is you're going to have, of course, you got zero line right there. The line in the middle, the line right there is your zero line. That's 0 volts. Well, that means this is moving above and below 0. So this grid's either going to go more negative or more positive. Well, when it goes more negative or more positive, you're only going to get half of that wave. So what's going to happen is you're only going to get you're only going to get the top half of this wave that's coming out to that plate right here. Okay, so that automatically will do something for you. Okay, and then the other part of it will be stripped off the ground. So basically, what I don't know how to say is you can use the negative or the positive. You could strip this top half off and use the bottom, because your signal that you're trying to get your signal through this radio it's here, but it's also a mirror image here. So you could use either side. So you just got to strip off one side or the other. And on this particular model, I don't know with a triode whether it's stripping the negative or the positive, but each one does the same. It'll still give you your audio. If you think about it, and I mentioned this in another video, if you measure from here to here on a modulated circuit and here to here, it's the same distance to your signal that you have here to here. And so if one's positive and one negative, well, those signals cancel each other out. And if you try to clip on to a modulated signal at the end before it gets rectified here in this, and rectification means we're taking half of the signal, whether it's the top or the bottom, half of that's going to go away. So when you rectify something, you're only going to have it on the positive side or the negative side, but you're not going to have it alternating between. It's the same thing we did over here on the power supply. It's the same thing we did over here where we rectified that AC and rectified it into DC where it's a straight line. Well, you got to do the same thing with the audio here, and what we're going to be doing now is we're just stripping off. We're stripping off either the positive side or the negative side, and when we do that, now we can hear the sound because it actually has. It's not canceling each other out. Because if you have a positive and a negative going on modulation, you're not hearing anything because you hear sound, but then it cancels itself out when it goes to zero on the negative side the same distance. But once we take away half of that, we can start picking up sound. Okay, and I hope I said that right. Okay, so we got two things going on here. We're rectifying that signal that's coming out of here. That carrier wave that is modulated, we're rectifying that, and we're basically demodulating that signal by what's going on inside this tube right here. Because we heated that, this can allow electrons to flow, and when we're allowing electrons to flow, some of them are flowing positive, some of them are flowing negative as it modulates itself. Well, part of that's on the negative side or the positive side, I don't know which one is dumping the ground on this particular tube, but it's dumping half of that off, and it's leaving a rectified signal coming out at this plate right here. Okay, that's the bottom line that you have to remember here, and that's the most important part, is you only have half of that. And so now it's not a modulated signal anymore, it's just a pure audio that's coming off of there. At the same time, we're dumping off that carrier, that 455 frequency is getting dumped off the ground, so you don't even have that. 455 goes away right here at the end, and the only thing you have is all you have left is one half of this, and all you got left is your signal. So you go back, we're going back, right back to this. And so basically we're just demodulating, like they modulated at the transmitter, we're demodulating it inside the radio right at that detector tube. Okay, so I hope that maybe I made that clear enough. The other things that happen is you got to be able to get that signal into this next tube, because this is your amplifier tube. So what it does, because you're demodulating, you're still going to have, like we showed on those other things. See, if you have a half of a signal, you're still going to have, the whether it's positive or negative, you're going to have the little humps. And so we have to clean up and filter those humps. So that's the next thing that takes place, and that's these little resistors and capacitors that's in the way. They'll come down here like this. It's coming off that plate. It's going to go down to the into the volume control. See, there's a capacitor right there, and that capacitor is going to go up. See, we got to get to that grid. That's where we're going to come into our next tube on the amplifier tube. And this is a shielded tube to give you no noise that you're going to pick up on that line. That's when you see the little dotted lines with the little arrow. That means it's got some metal around it that's grounded metal, and your wire runs through that, and that protects that audio going through there so it don't pick up noise from all these other things going on here. Okay, but bottom line is we're going to come off of there, and it's going to go through capacitors and resistors, and it's going to filter, and basically what it's going to do is where you got these little bumps in the line, it's going to give you nice clean audio, and it's going to start filtering those everything it goes through is going to filter more, and it's going to take more and more of that shakiness out of the, I don't know, that's a bad word, but basically it's going to filter that sound that's coming out of there, and you're going to have nothing but pure clean audio that hits this grid right here. That's the bottom line. All we're doing is basically the whole thing of that detector tube is to strip away everything that's green right here and give yourself one side, and just, this is your people talking at your sports podcast, and that's all you're going to get is that one side. And it could be that side or the negative side. A lot of people use the negative side. I don't really want to get into that on this video, but at the same time, we're doing one more thing here on most radios, is we're peeling off. If we use the negative side, where we have the negative side left, we can go down here and it kicks back around, and it hooks back in and kicks back into these grids of these first tubes, and what they call that the automatic volume control. Basically, I'm not going to get into that now, but just remember that there's another function right here that it will do an automatic volume control. So if you get a real loud station, it'll kind of tone the volume down a little bit, but if you get a real weak station, it'll tone the volume up a little bit automatically for you. It's automatic volume control, and that's all done right here by taking the half that you have on the negative side and taking that negative half and running it back through the radio, and it'll control that volume for you. So it'll keep your volume constant all the time instead of having weird loud points and real quiet points in your station. It'll help keep that balanced for you. Don't even think about that right now. Bottom line is, when we're coming out of this tube, we came into the IF section, switched over to 455 on the carrier wave. We get the end of the IF section, and we're stripping the carrier wave off through this pi circuit right here, and it's going to ground. That carrier frequency is gone, and then it dumps out on the top side. This is pure audio on one half of that carrier signal, either the top or the bottom's coming right in here, and then that gets over here, gets filtered and sent up here to the grid of the amplifier. Now, let's talk a few minutes about the amplifier. The amplifier, all its purpose is to increase the volume of what's coming out of here. You already passed through your volume control. Now we're going to come up here and we're going to amplify that signal really good to come into this final part right here. Okay. The next video. And I'm going to allude to it just a little bit, but I'm not going to talk too much about it. But the next video, we're going to try to take from right here over, and we're going to talk about the output stage. And this output stage does amplification. It does more amplification other than this. This is just going to bump that signal up really good coming in here. But it's gonna go into this little guy right here, and this guy has a purpose. Okay. And that's why I'm just going to kind of introduce you a little bit to it. This is called an inverter tube, and what it does is exactly what it says. Because you have two tubes, this is called, these are your output tubes. These are high-powered tubes. If you don't touch them, because they get super hot, like a couple hundred degrees, so if those tubes on top, if you just put your hand on them, you would burn yourself. These put out a lot of watts and a lot of power. This is what does the final business right here. But these two tubes are out of phase from each other. And I'll explain how all that works on the next video. But this guy right here controls that, because you have to send one signal in one way here, but then you had to reverse it and send it into this one the other way, because they're opposite each other. And that's what this tube that we're getting ready to come into, that's what that tube does. It converts the phase for this guy, and then it converts the opposite phase for this guy, and that's going to be his job right here. All right, so if we draw the line now, as we finished our video today, we're right here, and that's where we're at. All right, the next video we will finish this out. Now if I don't get it all done in one video, we'll do 2 videos on it. The way this thing printed out, if you look out here on the side, there's actually a little thing that has a thing, and it has a cone. It looks like that, that shows what the speaker is, and that's hooked right on the end of that right there. But my printer cut off the page, and I tried to reprint it and it did it the same way, so I don't know if it's something wrong in the way they uploaded it or what, but I did a horrible job on that cone. That doesn't even look like a cone, but I did it through the video. But basically on most of these it'll show like that, and well, that's a horrible line too, but it looks like a speaker cone, and then your wires hooked to the back of it. But this, I'll show how all this works to get your signal. Now you got nothing but pure audio coming off there, and so your whatever your podcast is doing, it's doing just the audio coming out of there, and it's kind of looks like that if you pull it up on a oscilloscope, and that's just every time it goes up and down, that's somebody talking. You know, so that's nothing but audio, no carrier waves anymore, and it just goes up and down, above and below zero. And there's things that happen with movement here that it puts it in where it goes above and below 0 volts. So I don't know how to explain that to you, but I will maybe someday come across a better explanation on that, how that happened, because we stripped that off, and you're thinking, well, you stripped it off, but you're above, if you use above one or below one, you're above and below the 0 volt line, but in this circuit here, things convert that to where it's back on either side of the 0 volt line, and I'm not smart enough to tell you how that happens, but it does. And the bottom line is, this is nothing but pure audio coming out of that amplifier into this inverter section, and we're going to see how that signal now that's going above and below the 0 volt line, how it goes here to this grid, and then how it comes down to this grid, and then they're opposite signals of each other. All right, that's what we're going to work on the next time around. And this is a very interesting concept, all this that's going on here. So I hope you'll hang with me. A couple of things, just side notes, has nothing to do with today's video, but I just like to point out each time we're in here that just little things, like where I pointed out the little dotted line means that it has a shield, like a metal wire around the internal wire, so that'll shield any noise. Well, here's another one. In between the plate, where you come out of the plate and then you get into the grid of the next tube, because it always moves from the plate of the tube, even though this goes through a volume control, but it goes to the grid of the next tube. It comes out of the plate. If you have a coil, that compensates for you too, but it ends up coming off the coil and then coming into the grid. As you can see, it goes from plate to grid, and this is how your audio path works. But if you think about it, when we were looking at the power supply, we just provided a lot of voltage to those plates. You know, they're running, what, 250, 225, you know, like a lot of these plates have high voltage. Well, if that high voltage is coming off here, it's going to carry that high DC voltage. It's also carrying your audio with it. Remember, you can run AC and DC on the same line, but you got high voltage right here. Well, if you try to run that high voltage into that tube on this little grid line right here, it can't handle that high voltage. It'll burn that up in just a second. These grids can't handle high voltage. So what they do is they put this, what they call a coupling capacitor. I don't know if I can zoom in on that or not. That's a good picture of one though. It's always between the plate and the grid. If you don't change out any capacitors in a radio, that's these old waxy capacitors like that, okay? Like that one and that one. If you don't change out any other ones, always change out the ones that are coupling between the plate and the grid, because these are the ones that can burn things up really bad. They can ruin your radio for you. So like C15, whatever value that is, you go down to your chart and you find C15 on there. Let's just, for the fun of it, look at that one, C1415. It's a 0.05 microfarad. So when you get into C15, don't ever bypass that and not change out those coupling capacitors. And you say, okay, well, there's not a coupling capacitor between that plate and that grid. It's just this coil. Well, coil does the same thing. Think about it. You have two lines that are not touching each other. It's separated. That line the line between those two, I'm gonna try to keep this flopping around, but you have a line there and a line there, but there's no wire connecting, okay? I'll explain how all that works when we get into the capacitors part of it. But the same way here, you got a line here and a line here and nothing's in between. They're not touching each other. There's no electrical connection there at all. That AC only travels across there because you create a electromagnetic field here, and AC can use that electromagnetic field to copy on the other side. That's how all these coils work. So it does the same function. Your high voltage gets dropped off right here on the bottom end of that. That high voltage goes off, but your AC goes across. So this is low voltage coming across on this side. Well, the same way, you're doing the same thing. Plate coming off here, high voltage gets stripped off, low voltage comes over here to the grid, so you don't have to worry about high voltage coming across these coils. Let's look at this one. The plate's coming off, you got a coil, and there's your coupling capacitor, okay? And so these are critical ones to change out. Now there's a lot of these other ones are critical too, but that's definitely the ones you definitely got to get first. All right, so and that's just a little tidbit. It really don't have anything to do with what we're doing right now, but I want to keep teaching you little things on these schematics so you can kind of see what's important, what's not important. Electrolytics is always the most important. Get those changed out, and when you get your electrolytics changed out, that's your real high value ones that are down here that are filtering your DC, and then you do these coupling capacitors next. All right, next video we're getting into this right here. We'll be talking about that. All right, thank you. Thanks for watching. Well, I hope you enjoyed today's video. Tried to go over a few things in the detector section and in the amplifier, the preamp, I should say, section. And then next video, we're going to be talking about the output stage, and to help you to understand what happens as you're going on into the speaker to be able to actually produce the sound, hear the sound that you've created all the way through this radio. And I think that'll be a fun one also. There's a lot there. I hope we can do it in one video. We might have to do that in two. We'll see how long that takes. So please like and subscribe, and hit that bell. I would appreciate any input that you can give me to help me to do a better job for you. Thank you. Have a nice day.